Hi everyone. In this video lecture, we are going to discuss about the various components of an immittance audiometer. This lecture is tailor-made for second year B.ASLP students. At the end of this lecture, the students will be able to list down various components of immittance audiometer and describe the basic functions of each and every component of immittance audiometer. Immittance audiometer comes with a display that shows the tympanograms and the reflexometry graphs that has been recorded. There are various buttons and dials on the tympanometer which act as the control panel, helping us to navigate through various test procedures and perform them. There is a probe assembly which enhouses the immittance probe and the contralateral acoustic stimulator. There is another important component which is called as the test cavities or calibration cavity. Without performing calibration, if we perform the tympanometry procedure or reflexometry procedure, the results may not be accurate or valid. This is the block diagram of an immittance audiometer along with the probe assembly. Here this picture depicts only the tympanometry assembly, not the reflexometry. The probe assembly has a probe microphone, a loudspeaker and the pressure transducer. If there needs to be a setup for measuring ipsilateral acoustic reflexes, then there will be a second loudspeaker over here in the same side of the probe. If contralateral reflexes has to be elicited, then there will be a separate speaker on the opposite side of the ear. The probe is placed in the ear canal with the help of an ear tip. The ear tip provides airtight seal in the ear canal, preventing the escape of any sound pressure or air pressure from the ear canal during the procedure. The immittance audiometer has an oscillator which generates probe tone. The probe tone characteristics vary from company to company. Usually it generates 226 Hz probe tone. If we require a high frequency tympanometry, then this probe tone might be from 1000 Hz. So here for understanding purpose, we take that it is generating 226 Hz probe tone. Usually the presentation level or the sound pressure level generated at the oscillator will vary from 60 dB SPL to 80 dB SPL. In this example, we confine to 70 dB SPL. The generated probe tone is delivered into the ear canal with the help of the loudspeaker. So the amount of sound pressure level that is sent into the ear canal is going to be 70 dB SPL. Now this sound pressure level is monitored by the microphone that is present in the probe assembly. It measures any changes in the sound pressure level that happens in the ear canal. The loudspeaker and the microphone are connected to the automatic volume control. This automatic volume control will make sure that 70 dB SPL is maintained in the ear canal during the procedure. The pressure pump generates air pressure. With the help of the manometer, it is made sure that the pressure is ranging between plus 200 decapascals to minus 400 decapascals. And through the pressure transducer, this air pressure is sent into the ear canal. The air pressure is used to keep the tympanic membrane at different positions and measure the conductance or the reflectance from the middle ear system. The admittance meter or the impedance meter displays the amount of sound that is conducted into the middle ear or being reflected from the middle ear. In this lecture, we have learnt about various components of immittance audiometer, the components of probe assembly and the basic function of each components. In the upcoming lecture video, we will be discussing about how the ear canal volume is being measured and the measurement of static compliance of the tympanic membrane, as well as how the tympanogram is graphically plotted. Thank you.